So similar to the differential equation which you just saw and asked, when you start solving physics, you will come across a lot of differential equation. And the first challenge will be to understand the meaning of variables and constant. Okay, that will be the first challenge for everyone. So imagine if I'm giving you a simple question: a equals to minus b. So at first go, do you see this as a differential equation? So we need to go back to the definition of a. What is a here representing? Basically, a is called acceleration. And if you remember, acceleration is a way of writing something else. So what acceleration represents, if you remember, from the dy by dx rate measure?
dv by dt.
dv by dt. Great. Now, once you write like this, do you see the integrator? So how many integrator we have here possible? Integrator means what? The d term, dv, dx, dy, dz, dl, whatever. So what we have here as an integrator, can you see the variety of integrator? So you know how the v will change with time, that is known to you. And now you're looking for, you know how the change is given to you. And from the change given, you want to figure out what was the relation between v and t. So it's a reverse process of thinking. You know that the change is bv. So what kind of function upon differentiation will give you this answer? And this is what you have to think about. Understood? What is the question? You know the change and you're trying to guess the actual function which upon differentiation gives you this answer. And that's very, very interesting to understand. A function which gives you the same answer even upon differentiation with some constant. Can you guess the function? Which function in mathematics gives the same value even after you differentiate? Any guess?
So e to the power x.
Excellent. And that's the first guess, and the first guess is correct. Any question like this always represents what? Exponential relation. Because only exponential can give you back the same answer. And that's pretty interesting. That a function upon differentiation is giving back me the same value or the same function, it must be exponential. Now let's verify through the mathematics. So dv by v is equals to how much? Minus b dt. Okay, first step is okay. I mean, of course, it will take some time for you to digest. But the first step is we rewrite the terms like this. Like this means what? Every d term should be in the numerator. So now the first integrator here is dv, the second integrator here is dt. So do you see the integrator? So now tell me, is it possible for dt to integrate v value? Is it possible? Can dt integrate v?
No.
Yes or no? So what is the logical step? What is the logical step to go ahead? What should I do here?
Take minus dv to the denominator.
I'll bring the v here on the variable of one type. This is called the variable separable. So that is a logical step, and this logical step is very important to you, for all of you to understand. That we bring a variable of one type on one side. And what is the next step? You integrate both sides. See, I have taken the integration inside because b is a constant. So that is the choice given to me. Now, when you solve the real phase question, then you will know the initial condition. that what was the velocity when you started the journey. So that is represented called initial condition. We will talk about something called initial condition. So there are two ways. I will show you the two approach. The first is you keep the initial condition handy. So let's say it's given to you, given at t equals to 0, the velocity is v naught. Let's say this is given to you. So you do a normal integration the way you do. So this will result into integration. What is dv by v integration? Tell me, guys. dv by v, similar to the dx by x. What is the integration? Siddhant, tell me. What is dv by v integration? It is similar to dx by x.
Log V.
It is
Log V plus V.
log v. So as of now, just you got log v, ln v. And on the RHS, what we can write? On the RHS?
minus b d square by
Minus b. What is
minus
the
b
integration of
to
dt? What is the integration of dt only?
t.
T.
T. And because we haven't put the limit, so we have practiced plus, because we are not aware about the condition. So what you get is ln v is minus bt plus. Now to evaluate the c value in physics, we always look for the initial condition. So they give you something. So what they are saying is that if you put t equals to 0, you must put v equals to v naught. Okay, so let's do it. So I'm putting v equals to v naught, and I'm putting t equals to 0. And this will give you the direct answer of c. What is c here? ln v naught. So what is the next step? You will substitute in the unknown ln v minus bt plus ln v naught. Okay. And therefore you can write ln v minus ln v naught is minus bt, which is ln v by v naught is minus bt. And but we are looking for v value, so ln will go this side. So when you take ln on the other side, what it becomes? So when we take ln on the other side, it becomes exponential, right? And therefore v becomes v naught e power minus b. And that was the initial guess also, that it should be something like exponential, because only exponential upon differentiation gives back the same function. So it's very interesting to see, and such kind of questions are very much you can say relevant in physics, that the dv by dt is minus bv, which means a function upon differentiation producing the same function, and that is probably exponential function, and we are getting the answer very much, which is defining the condition the way we expected. So I hope this is done. This is clear to all of you. Now, what is the other way of using the initial condition? So method 2. In the moment of integration, the lower limit always gives you the initial condition. So when t is 0, the v is v naught. So at any random time t, the v will be v. Understood? Are you guys getting the way of writing? How to use the initial condition? You can put as a lower limit. So that's the takeaway, that in physics, we always take the lower limit as the initial condition. and then upper limit will be the in general condition. And what you do next? You integrate the way you do, and then you write the limit the way I'm writing. Lower limit, upper limit. Lower limit, upper limit. And what is the formula for definite integration? ln of upper limit. So you substitute the variable by upper limit, and you subtract the variable with lower limit. T, so replace t by t, and see we are replacing t by t value, and we are replacing t by 0 value, the limit. And it is quite possible to have the limit similar to the variable. So this will become, by definition of properties of logarithm, we can write ln a minus ln b as ln a by b. And therefore, what you can write, v equals to, and now again, it's the same thing. So whenever we have ln, which means log base e v by v naught is, so in a logarithm, what we learned is that this is called the power. So the base to power gives the value. How we understand? Base to power, this is the power, this is the base. So when this base is raised with this power, you get this number. So we can write v by v naught is base to the power. That's it. So this is a very famous exponential relation of v and time. Okay. So I hope this is clear to all of you.
Yes, sir.
How to solve the differential equation? Okay. So acceleration is very interesting in kinematics. So we'll explore more about acceleration. So A, we write as dv by dt, the rate of change of velocity. But sometimes we would like to express A in a more fancy way. So this is called the time dependent relation. And we do have something called displacement relation of acceleration. So A is very fancy. I mean, A, of course, you can write like this, but A can also be written in a more fancy way. And how, what is the best way of writing? So time is not the only variable. Sometimes you want to express in terms of other variable like position. So we can write as a ds. I'll change the color. It's like a chain rule. The dv by dt can be rewritten as dv by ds into ds by dt. Okay. So from where it comes actually, so let's say we have a path, a random shape path. It's not a straight line. And you're moving along this path. So you move from here to here, a very tiny displacement. We call this as ds. And the direction of instantaneous velocity will be along this line. So we call it v. So tell me guys, how to write v first of all? What is a v? So at t equals to 0, you are here, and at t equals to t plus dt, you are here at this location. So what is the definition of velocity? Velocity is how much you traveled in how much time, right? The displacement upon time. So how to write v, guys? Tell me. In this case, come on, tell me. V equals to
ds by t plus dt.
ds by how much time it took to go there from here to here?
T plus dt.
No, no. How much time it took the? Oh, sorry. Oh, my bad. This is wrong. This is t and this is t plus dt.
dt.
Now dt. Yeah, excellent. So time taken to go from there to there is a dt only, no? And how much you traveled? ds. So what is the velocity? ds by dt. See, everything in calculus is from the basic definition which you know. So v is ds by dt, and now you can realize that this ds by dt can be replaced by what? We can replace by v. Yes or no? Do you realize this? Hello, guys.
Yes, sir.
No. So therefore, the A can be rewritten as, and this is the second famous definition of acceleration. Now, before you jump to the solution, try to understand from the context of physics when we need to think in this particular way. So you know the variation of A, and it could be given to you as a time varying function, but it could also be given to you as a what? Displacement dependent function, or it could be given to you as a velocity dependent function. Okay. So A is such a versatile function that can appear in multiple ways. So in general, in the entire physics, not only in this chapter, in entire physics, you have to deal with three types of dependency of acceleration. So there are three possible dependencies of acceleration. So what are the possibilities of, dependencies of acceleration? It can depend on what? And everything is in front of you. So when you're moving, what are the parameters which you associate with when something is in motion? I can say velocity, time, and position. Okay. So for every motion, there are only three dependencies in nature. There is nothing like fourth dependency. So we say that A can depend either on time, which is very much common. The acceleration can depend on very much displacement or position. Okay, both are used interchangeably. And the third dependency is which you have to face always is called the velocity dependency of acceleration. Okay. So in a way, when you start your bicycle also, if it is at rest, you can create maximum acceleration to change the velocity. But imagine if you're at the highest or maximum velocity which you can probably paddle, how difficult is to accelerate further? Is it more difficult or less difficult when you are at already high speed? What do you think? Is it more difficult to accelerate at high speed, or is it less difficult to accelerate at high speed?
More difficult.
Because as you gain the velocity, the chance of changing it further is very less, right? So in
Yes,
our
sir.
day-to-day life, it is very common experience that we cannot produce the acceleration at every speed by same value. So it is very much relevant, I would say, that the velocity dependence of acceleration is there in nature. We have all been facing this since our childhood. Okay, so that is one way. Okay, that more the speed, more the lesser the expectation of change of acceleration. Now position is what? So as you move, okay, so it is quite possible that the acceleration may be position dependent. So it is possible that the surface on which you're walking is getting or having lesser and lesser friction. So probably as you walk further and further, you'll find more difficult to run. You may slip easily. Or maybe I can create a surface in which the friction will keep on increasing. Then again, it will be a varying experience of acceleration. Sometime on Indian roads, if you're driving your car, you feel that okay, car is suddenly getting too much traction. Traction means the grip from the ground. Okay. So the traction is a way of saying that it is getting a lot of friction to accelerate itself. And in a way, the car is in more control of the driver. So again, it is the nature of the tire and the road which combinedly decides the traction or the friction. So if I have a variable surface, if I have a surface with varying property, then I can again create the time dependence acceleration. Position dependence acceleration. So these are the three, you can say, variables on which you will come across the dependencies of acceleration. Okay. So now the question is, when to use which relation of acceleration? So we definitely have this relation, and we do have this relation. So let's think logically without getting burdened by the physics. So if a function of time is given to you, let's say if acceleration is given to you as a time function, if acceleration is given to you as a time function, then which relation you will go with logically? The first or the second? Let's call this as first. And this is second. Which one you will go with logically? Because eventually, remember, eventually you have to solve the differential equation. So you have to think in terms of the feasibility of solving it. That's mathematics. So tell me, what is your logical step? How you think about
The first one.
first? Very good. So it is logical to begin with or start with this relation. Now, tell me, guys, if I have a function of position, what is the logical step to move? The first or the second?
Second.
Second. So I will go with VDE by. See, we are thinking or making a logical decision. It is not something which is imposed by subject. I would say it's a very much common sense that if anyone solving mathematics, they must understand that at the end of the day, your goal is to solve mathematics. So any form which is not feasible is not solvable at the end. Okay. So we have to think about the feasible way of solving the question. So that intuition should come to you naturally. If it is not coming, somewhere you're not learning math in the right way. Okay. Now, third is very interesting. Third is quite fascinating, I would say. So in case of third, when F is velocity dependent, and that's why I'm changing the color, what do you expect for the third case? Can we use the first? Can we use the second, or can we use both?
So both.
Excellent. You can use both. So now how you're going to make the choice? If you can use both, then our choice will depend on. Can you guess what will decide our choice? Because we can use both. So definitely, we are going to use both. We can use both. Now, choice will depend on the problem statement. That's very simple. Don't worry. So now it is not the mathematical choice. It's a choice as per the context of problem. Like what kind of a relationship you want to derive? Do you want the time-based relation or do you want the position-based relation? So depending on the context of problem, or you can say basically the statement of problem, we have to choose the correct one. Now we are free to choose both of them. So our luxury is that I can choose both. But even though we have multiple choice, when you're going to solve question, you cannot write two equations at the same time and solve. So you will choose one and will proceed accordingly. So now definitely it is the the choice which depends on the what they expect from us. So this, I mean, I can choose either a equals to dv by dt, or I can choose a equals to v dv by ds. So you can choose any of it, and that's not a big deal. What I'll do is I'll show you some of the examples, and we'll see that now when we write the acceleration in this format, the format number 2, this way of writing acceleration is called tangential acceleration. So we'll come to know this later on, because you can see this acceleration is pushing you, in the direction of motion. So this we write as tangential acceleration. And why we call tangential? Because it will change your speed value. So it has to do with the change of magnitude of velocity. Of course, we do not talk about direction here. So the acceleration which affects the magnitude only we call tangential. And then we have acceleration which only affects direction, we call it centripetal. And then we have something called acceleration. So when we say acceleration, then we do not put any constraint of nature of variation. A word acceleration refers to, you can either change the magnitude or direction or both. So to be more precise, as long as we are solving the question of one dimension, in one dimension, do we change the direction or only we change magnitude? What we do in one dimension? Tell me guys, in one dimension, what we do generally? Let's say if I give you a fixed line to walk, so I'm forcing you to move in a fixed direction. So what I'm going to change possibly there? Only
Magnitude.
magnitude. So that's the logical way. So when we talk about one dimension, then acceleration by nature represents the tangential acceleration. And that is why in one dimension, it is not required to explicitly mention in the problem. It is like but natural. Okay, we expect that, okay, even though they are not saying it explicitly, one dimension force us to understand or believe that the acceleration they are talking about is tangential acceleration. So when you have been writing the equation v equals to u plus at, was that acceleration? And if yes, then which acceleration? Tell me. So in the formula of v equals to u plus at, what we write? The v represents what? A represents what? The tangential acceleration or the acceleration in general? Tell me guys. So when someone is writing a formula v equals to plus 80 in a for motion in one dimension, so in one dimension, this a represents what?
Acceleration.
Which acceleration? The magnitude change or the velocity vector change?
So the magnitude.
Only magnitude. So this is by default, this is tangential. And now you realize that, okay, whatever you have studied in class 10th or 9th, the a was one of the part or one of the, you can say, component of acceleration. So the moment we enter the world of two dimension, the acceleration will have different meaning, and therefore this kind of changes will appear some confusion also. So let me make it very clear that acceleration will have two types, one which affects the magnitude, another which affects the direction. And the acceleration word means for both actually. So if you want to talk about one of them, you have to make other quantity fixed. So if you make the magnitude fixed, then the acceleration will give you the centripetal, and if you keep the direction fixed, then acceleration will give you the tangential, and if you do nothing, so you have to deal with actual acceleration. So that is a part of our circular motion chapter. That's the third chapter. So third chapter is all about extension of the idea from 1D to a generalized idea in a plane. So that's called the in higher physics we call motion in a plane instead of calling it circular motion. So circular motion is a part of motion in a plane. Okay, anyway, so coming back to this derivation, what we can do with all this formula? I mean, if these are formula, and every formula which we have written here, these all are called differential equation. So in mathematics, these are called differential equation. So differential equation is a very nice way of writing the relationship with incremental changes. So what happens if I make a small change in this? How much the other things will get affected? So let's solve some of them. And it is very interesting. Okay, so A we can write as what? dv by dt. So what I'm going to do is, for constant acceleration, for A being constant, let's say A is a quantity which is constant. So if something is constant, then it's very easy to integrate. Just take it out of the integration, isn't it? So if A is dv by dt, so someone is saying you or telling you that, see, the rate of change of velocity is fixed. Tell me a common sense, which kind of graph represents the constant change? What you differentiate to get constant value? Common sense. What kind of function upon differentiation gives you constant? Can you guess? Tell me in terms of y and x. Y equals to what we must write so that such that if I differentiate, I'll get a constant.
X to the power n.
But if you differentiate x power n, will you get constant?
N is the constant.
I just need only constant. So what is the differentiation of dy by dx here?
Nx to the power n minus 1.
Okay, very good. Now I do not want x. I just want a number. I do not want x. How to get rid of x? What value of n will take away x from here? Common sense. The x will vanish if n is equal to how much?
1.
1. Very good. So basically, I just need y equals to a linear function. I would say ax plus b. Any linear equation, when you differentiate it, because the differentiation meaning is slope of the curve. So when the slope is constant, only for straight lines, the slope is constant. Do you realize this? Do you all realize this, that the differentiation represents slope of a tangent, and slope is constant in which kind of graph? Slope is
line.
constant only for straight line graph, isn't it?
Yes, sir.
So we talk about the linear function. The slope is constant for the linear function. So the way of looking at this formula is that the slope of a graph, which graph? V versus T graph is constant. So when I say acceleration is constant, indirectly I say slope is constant. So the V and T graph must be looking like the graph between V and T must be
Straight line.
a straight line. Then only A will be constant, isn't it? The slope is constant. And we know slope is constant is only possible for a straight line. So the relationship between V and T must be straight. Then only this is possible. Yes or no? Do you guys realize this? That A is a way of saying, when I say A is constant, I'm saying that the V and T relation is linear. True? Are you guys getting this? Hello, hello.
Yes, sir.
Okay. So what is the next step? We want to find the V relation with time t, given A is constant. So we can write as dV equals to A dt. And A is just like any other constant. So what you do, you integrate both sides. So when t is 0, the velocity you generally write as, what you write? U. So when t is t, what you write? A general value V. So U is called the initial velocity, U is the initial velocity. So when time is 0, the velocity of the particle at t is 0 we call initial velocity, or the symbolically we call U. And let's integrate. The LHS dV will give you how much? dV will give you integration V. And what is the limit of integration? U to V. A is anyway a constant. What is the dt integration, guys? Tell me.
T.
T.
And then how we use the limit, upper limit minus lower limit, right? So what we will get here? V minus U equals to AT. And so we get the first kinematical equation, V equals to plus AT. Now tell me, is this equation applicable every time for any kind of acceleration, or is it only meant for some kind of acceleration? And what kind of acceleration? When this is applicable formula? When you know that acceleration is
Only for straight lines.
only for constant acceleration, isn't it? See, we derive the formula with the assumption A is constant. Yes or no? So should we use the formula when A is a function of time t? Should we use the formula when A is a function of position? Should we use this formula when A is a function of velocity? Yes or no? Tell me.
No, sir.
We cannot use this formula for acceleration until it is not a constant value. And that is why the kinematical equation represents constant acceleration relations. Okay. So given that A is constant, what are the possible relationships that we can think about? Understood? And that's why we, in the very beginning, when you will start solving the error or in kinematics, the common mistake is that you start solving question even applying the formula V equals to E plus AT for those acceleration which is a function. So they will give you A equals to 2t, but you will also apply a V equals to E plus AT, which is wrong, entirely wrong. Any acceleration which is not constant, we are not supposed to use the formula. And this mathematical derivation gives you the idea that under what condition we derive. I hope this will something which you can remember. So fine, we got V equals to plus AT. Can we get something else? So V is defined as ds by dt, if you remember. Yes or no? And we know that the V is given to us in a time function. So can we write ds by dt equals to V? Just a moment. Okay. So continuing the same derivation, we know ds by dt is v, but v we can write as u plus at. Now tell me guys, what is u representing? Some constant or some variable? In this entire equation, what is variable? Can you guess the variable? What is variable here? Tell me.
The time.
Time is a variable. Okay, great. So everything else is constant. So now how to solve this differential equation? So ds we can write as u plus at into dt. And then because everything is either time variable or constant, so there is no need to reshuffle anything and you can just integrate. So I will say ds as s, it's called displacement. And then the u and dt, what will get the first answer? U dt from 0 to t plus a t dt from 0 to t. Okay. So the first term will give you what? U is a constant. So can we take it out of the integration? And a is again a constant, so we can take it out of integration. So tell me guys what you're getting here. U. So what is the integration of dt?
T.
And 0 to t will give you t only. And what is the integration of t dt?
T square by 2.
T square by 2.
So now you know the relation, no? Ut plus half a t square. And see, the calculus is a way to derive every formula in physics. Again, under what condition this formula is true? When a is constant. So we use this relation because a was constant, and so we got this answer. So again, this is only true. So in fact, every canonical equation is only true when a is constant, and therefore the moment I will give you the next question, which when a is variable, you cannot solve. And the third canonical equation. In the third equation, canonical equation, if you remember, the time, the t term is not there. Okay? So we don't have t. So to get a relation without t, which relation of acceleration should be used? First or second? Common sense. You do not want t.
Second.
So you will definitely go with second. That's a logical step. I mean, no is going to force you to use that. That's the logical way of going ahead. So we'll add v dv by ds. Now, luckily, a is a constant, so I can take a on and ds on the one side. So I can add a ds is v dv, and because again a is constant, so I'm taking out of the integration in the very first go. So when you begin, your speed is u, and you travel nothing, and after some time your speed is v, and you travel something. That's called s. So LHS will give you how much? Tell me, guys. What is LHS giving you? What is the integration of ds?
Yes.
Yes.
So as equals to, and this is v dv will give you how much?
V square by 2.
But you have to also take the limit, na? From where to where? U to v. So what you write here? Tell me.
V square minus u square by 2.
Correct. So now you know v square equals to u square plus. That's very simple and basic relationship that we are all aware of. Okay. So you can see that integration is a way to go back to the relationship. So when you know the variation, and when you look for the actual relation, you first write the variation relation, which is called differential equation. And every differential equation is integrated to get the previous equation from where you come to this equation. So when you know the differential form, you integrate to get the actual form. Okay. So that is a logical way of moving in physics. The moment I know the differential form, I'll try to get the other form. So I'll stop this part here only. And in a way, you have already finished the motion in one dimension. But let's see what happens if a is not a constant. So let's say if I give you a equals to, let's make it simple value. A is 2t. Can we use the Kinematical equation, V equals to U plus AT, S equals to U2 plus half T square, or V square equals to U square plus 2S, yes or no? Can we use it? Everyone tell me.
No.
We cannot use it. And since we cannot use it, so what is the way to approach? We have to start with differential equation. So what is the first differential equation that I must express A with? Should I replace A by the first or second?
dv by dt.
Very good. And now you can see that which kind of variable can be bring or brought together. So first of all, I need to bring the dt in the numerator. So without thinking, just write dt like this. Now think, do we need to reshuffle the variables or is it okay?
It's fine.
It's fine. Very good. So we know it's fine. I'm not giving you any initial condition, so you can just write the C and you're done with the answer. So we can write V equals to T square plus C. So when you're going to solve the actual question, you have to think about the initial condition, and that part I'm leaving so that you can have some exercise when you solve actually. And from there you can evaluate the C value. See, again, there are two ways. Either you write C and try to evaluate using the condition known to you, or you take the condition as a lower limit and solve. Whatever makes you comfortable, go ahead with that way and stick to it for your life. That's totally okay. So V equals to T square plus C. Is this clear? Okay. Let's see if I give you another question that A is minus some constant into S. Okay. Can we start with the first form of writing A? The differential form. Is it suitable to go ahead with that? Tell me yes or no.
No.
Should be or shouldn't be?
No, sir.
Okay. So what should I write here? Tell me. So I can replace A by?
V dv by ds.
Very good. And what is given to you? Minus Ks. Before we solve anything, we need to bring the ds term in the numerator, because these are going to become the integrator of future. Now, do I need to reshuffle or is it okay?
Sir, it is okay.
Very good. So this will give you V square by 2. This will give you minus K s square by 2. And I'll just start C and then I'll leave it. And then comes the third part. So if I write, okay, I have already written this part. So I started with that only, today's lecture. So if I give you A equals to minus B, that's very famous. So this is called the drag force, or this is basically if you move through a viscous medium, a medium which offers resistance, the faster you move, the more resistance it will offer. So for example, if you try to ride a bike, the faster you try to ride, it will have more air resistance. So that's logical. And minus is saying that it is always opposing. So if you try to ride a bike, definitely the air drag will not support your motion, but rather will oppose your motion. Okay, so this is the whole idea of relations. This is a very much a natural occurring event in nature. So when acceleration is a function of velocity with this relation, now the context will come, the idea of context. What I said is, I am free to choose now either first or second, yes or no. So we can choose both. Tell me, guys. We can choose both, yes or no.
Yes, sir.
So let's say if I ask you, find the relation of velocity and position. Find V versus S relation. Then what you will go with? The first or the second?
Second.
So go ahead and tell me the relation, everyone. Tell me the relation quickly. Create the differential relation and go ahead and tell me the answer.
So it is B constant.
Yeah, B is constant.
So V is equal to minus BS.
Correct. So V dV by ds, but you can see the V gets cancelled. So what we get dV equals to? So V is minus BS plus. Is this your answer, Siddhant?
Yes, sir.
Very good. Hmm. So imagine if I give you a question like this. A equals to minus alpha root V. So A is accession, alpha is some positive constants, alpha is positive constant. No need to worry, the symbolic monsters are there. Okay. And at t equals to 0, when you start the motion, the velocity is given as V naught. So the initial condition is given to you. So I want the relation of V versus S. Find this. And I want exact relation because I have given you the initial condition. So can you go ahead and get the answer for me? This should not be difficult. I hope so. Once you understand the concept in physics, it is only cosmetic. In just you have to do the basic calculation and get the answer. So to get the relation, you should proceed with which relation? The first part, first form of A or second form?
Second form.
Very good.
So is the answer 2V to the power 3 by 2 by 3 equals to minus alpha into S.
Maybe. I will just check. No. The V power 2 by 3 will not come. Something simple will come. Ah, yeah, no, it will come. Correct. Yeah, it will come. So tell me the answer, what you're getting. That is the right answer. Just
2V to the power 3 by 2.
Okay. So tell me the answer. Tell me the answer.
2v to the power 3 by 3 is equal to minus alpha into s.
Minus alpha into x, like this.
Yeah,
And then you have to add plus c also. Plus c also, no?
yeah, plus,
You haven't used the initial condition, right? So now using the initial condition, can you find the c? At t equals to 0, when you start, what is the s value? How much you will travel? Nothing, isn't it? So when t is 0, s is also 0, no? So put s equals to 0 and v equals to v naught, and you will get the c. And then you can substitute it. Do you realize this? After putting s 0 and v equals to v naught, we can get c. And once you substitute the value, what you get? So this is the relation. Okay. And you can also see something here. As you move ahead, your v will decrease or increase. Can you guess? So you can write as v by 3 by 2. So as you move ahead, as s will grow, this term will decrease. Okay. So when you move ahead, you will slow down and eventually you will stop at some place. The moment you stop is your maximum displacement, because that is where you will stop and probably come back. So we say that for maximum displacement, what we can write? The final velocity equals to 0, because you will keep on moving ahead till you have some velocity left. And the moment your velocity is 0, you will come to rest. So the moment you put v equals to 0, you will get something nice answer. If you put 0, I'm writing directly 2 by 3 alpha. Is this clear, guys? Tell me, yes or no?
Yes.
Anyways, if you have got the first lesson, that is good. And this was the error of question 1.23, which you just solved. So all error questions are basically mathematically you can say a good question for manipulation, but they're not very conceptual. So it's a very much a routine job. If you're good with maths, I mean, you find the error to be generally not very challenging. Okay. Next. So I'll give you something random. I mean, something random. Let's see how your brain is able to understand the differential equation. So what I'll give you something E equals to IR plus Q by C. Okay, something I'm giving random. And I'm giving you I equals to dq by dt. Okay. And let me tell you what are the variables, because you can see from the relation that q, we are differentiating q with time t. Because we are differentiating q with time t, it means it must be a variable, isn't it? So the first idea is Q is a variable. What are the other variables you can think of? T. What I'm looking for? I'm looking for charge. I mean, of course, let's say you don't know about this. Let's say Q is some variable. I want the relation of Q in terms of time t. Everything else is constant. Everything else is constant. Everything else. Okay. So all are symbolic constants. R, C. So E, R, C are ERC are symbolic. Don't think that this is some mathematics. I mean, some physics. Just some symbolic, a notational thing is given to you. So the first step is get the differential equation. So we know that I is dq by dt. So I need to get I first from the first equation. So get your differential equation. Get your differential equation. So how to get your differential equation? Because we know only I is a differential. So differential equation means there must be some dy by dx term in the equation, then we call differential. And because I can be written in that way, so I can say, okay, that is the differential. So to get your differential equation, what you can do? You will rearrange the term. So you can write I equals to E minus Q by C. And now I can write I equals to E by R minus Q by RC. And this is the differential equation. Do you realize this? Why this is differential? Because I can further substitute by which relation? dq by dt. So I'll take LCM here RC because it looks nice. So the first step is to solve any differential equation. The first step is you bring all the d term in the numerator. Now tell me, do we need to reshuffle something here? Do we need to reshuffle? Rugved, tell me. Do we need to reshuffle?
Yes.
So which term I should reshuffle?
Q.
Only Q is possible to reshuffle?
Q by RC.
Only QRC is possible to reshuffle? Are you sure? What we can bring here on the left side?
The whole equation.
The whole means the whole.
EC minus Q by RC.
Is it RC required to bring it this side? Because
No.
R is constant, C is constant. So do we need to bring it this side?
No.
So what is sufficient and prerequisite? Like we must bring it on the left side.
EC minus Q.
Excellent. It is the EC minus Q, and that is a logical, I mean, logical reshuffling, isn't it? See, you cannot bring Q this side. RC is not required to be brought. Even though if you bring, nothing will happen. And the rest you can really leave as such. Anyway, RC is a constant. It will take, it will come out of the integration. So the next logical step is integrate. And then write the answer. So here I will give you the limit or the initial condition. So take at t equals to 0, q equals to 0. Okay. So when you know the initial condition, where we put these values? We put these values as the lower limit of integration. Understood? So when t is 0, the t is 0, I should put on the right or left? The t equals to 0 will be the lower limit of a right side integral or left side integral. Tell me, guys.
Right.
Right side.
And q0?
Left.
So when I put t, which is the general value, because we want t relation, so what I must put here on the
Q.
left? Q. And can you integrate it now? Can you integrate it? Tell me. What is the answer?
So minus 1 by epsilon c into ln q equals to t by rc.
Minus
Minus 1 by epsilon c into ln q.
into LNC.
So q,
You.
yeah, equal to t by rc.
But how this is possible to integrate? You can take EC left and you're integrating LNQ. I mean, how this is possible? Do you think this is correct?
No, so sorry.
Something is missing here. Just recheck. So this is in the format of dx by x, right? But here x is not alone. It is x with some constant. So this is just a number, no? So how you integrate when you have a linear value? The answer remains same. Or you can use the method of substitution as you wish. Then guys, got the answer?
Yes, sir.
Tell me Siddhant.
So it is log of EC minus log of
EC minus just only EC.
no, sir, log EC upon 1 second.
Okay, log EC upon. Okay, fine. Tell me. Log EC minus
Log EC minus log of Q minus EC.
U minus EC or EC minus Q?
EC minus Q. EC minus Q is equal to T.
T by RC.
Yeah, T by RC.
Yeah, that seems correct. Maybe this is EC minus we can. I think minus. Okay, you missed the minus part. Anyway, quite close. So if this is not in the format of dx by x, what you can take? You can let's let x equals to EC minus Q. Okay. So when you find it difficult to understand how to go ahead with this, you just take it as x. Then take differentiate. So dx we can attach. All constant will vanish. We have getting minus dq. So we can replace dx or dq as minus dx, and then you can look at this formula becomes simple. Minus dx upon x, and the answer will be minus ln x. That's it. And what is the x assumption? So basically the integration is minus ln EC minus Q. That is the integration value. And then the limit you have to put 0 to Q. You can take minus on this side directly. So what you can write here is ln EC minus Q, the upper limit, minus lower limit is how much? EC minus 0. So what you get is EC minus Q upon ln C. Okay, that is minus E by RC. And then you can take the logarithm, take the log, reverse of log, anti-log. So what we get here is EC minus Q by EC equals to E power minus T by RC. Then you can rearrange. So you will get the answer EC minus T by RC. So differential equation is a way of life. I mean, you can see that, okay, it is not just in physics, but in most part of in chemistry, also in chemical kinetics, you will come across. It is everywhere. Okay. So one last before we move to the our major topic of the day. So the next is if the rate of change of some number is given as this, some constant into number itself. So the differentiation of a number is some constant into number. Can you guess without solving what is the number must be? This number must be which function? Differentiation of a function with time gives you the same function. So when this happens, we have done this today.
It's a linear equation.
Linear. If you differentiate linear, you get linear.
e to the power x.
Correct. E power x. Only exponential upon differentiation gives you the same value, isn't it? Exponential.
Yes.
So you are differentiating n, you are getting n. N must be exponential, no? And because you are getting some negative numbers, so it must be a negative exponential. That is also logical. So given at t equals to 0, n equals to n naught, can you find the n as a t function? Find n as a function of time t. Tell me guys, what is the answer? So Shreya, are you solving integration? So you will send me your work on my WhatsApp number, like how many pages, like how many questions solved. So I would like to see everything. So send it by today first, like whatever you have solved so far, send me today. Everyone else also. Yeah, what is the answer for this answer, guys? Tell me quickly.
Sir, e raised to power minus lambda t is equal to n.
Only that's it. N naught will not come. What is n naught?
N
N
by
naught is equal to 1.
N naught equals to 1. N is given n naught. Yes, Rugved, tell me what you got.
n by n naught equals e raised to minus lambda t.
Very good. So you're missing the limit, I think. Siddhant, check it out.
So here t is 0, no, sir.
So when t is 0, then n is n naught, but not in general. No?
Okay.
How you find the c value? Yeah. So this is what you will study in two chapters. One in chemistry called chemical kinetics, and other is in physics called radioactivity. So this is basically the disintegration law of disintegration. So in physics or in nature, I would say, these are very typical differential equations which you will face. So I can give a lot of, I'll give you some questions for practice. So let's say acceleration is given by alpha minus beta v at t equals to 0, take v equals to 0, find v as a function time t. This is homework, no need to solve now. And you can solve okay, just any relation. So here the differential equation, you can directly guess what is the differential equation here. What relation we need to find here? Can you guess the question from the equation? What you are supposed to find? The relationship between
I in
which?
terms of t.
Very good. Excellent. So now you got the whole idea. If you understand this part, you actually understand physics very, very well. What you need to know is important. It really doesn't matter whether this belongs to what chapter. We are not supposed to know any chapter name. If something is given to you, we should know how to solve it. That's it. This is again homework. So you're supposed to find I is a function of time t, and let me give you something like so find tangential acceleration. That's simple. Okay, so we have seen one part of integration where we need to actually integration is basically employed whenever we come across a differential equation. So from differential equation to go back to the integral form, we integrate. Okay, so you know differential form, and you go the reverse process to get the actual relation. So it is like if I have this as integral, I mean differential equation, it means what was the actual relationship between I and t which led to this equation. So that is called the differential equation. So of course you can take here I equals to 0 when t is 0 as initial condition. All right. So now we are going to start something called elementary in physics. So what is the meaning of elementary in physics? Okay. So we have discussed this. Let me reiterate once again. The only formula of area that we are knowing, that we know, is area of rectangle. So what is the area of rectangle? So if we have a rectangle of length L and breadth B, what is the area?
Length into breadth.
So LB is square units, right? So this is what we discussed in the very first lecture of integration, that the area is length into breadth. Okay. That is the whole idea. The length is only two things. I mean, say area is only depending on two things, length and breadth. Any other area which you know cannot have a formula, but we have to derive from the rectangle. Okay. So because we know only one formula, that is area is rectangle, so we always try to convert every shape into, you can say, collection of rectangle, and by adding area of each rectangle we get the total area of a given arbitrary shape object. So let me draw one graph, something like this. If I draw a line like this, and if I draw a perpendicular, is it possible to find this area if I know the height and if I know the x coordinate? Can you find this area? Yes or no?
Yes.
How much is this area?
AB.
A. Okay. So why you were able to find the area? Because you know the answer, right? You know this is rectangle. So you know the formula you applied. So if I draw something like this, so what is this area?
LB by 2.
So comes the third figure. So now tell me what is this area? Do we have enough formula? Any formula left for us?
No.
So what we will do? What is the logical way of doing this? So what do you know? Tell me what do you know? Which area formula you know?
Rectangle.
Only rectangle. And do you see rectangle here?
Yes.
How many?
2, I guess.
Two rectangle. Which one? Can you annotate? I would like to see.
One from 0, comma y1 to
Oh, you mean to say you're seeing this part?
no, x2, comma y1 and
Okay, you mean to say this part?
huh.
But I'm saying the rectangle in this shape. Is this shape rectangular at all?
No.
So do we know the area? Do we know the formula for this? Can we write a formula for this? Tell me guys, can we write the formula for this? The answer is no. We cannot write formula for this. Understand? So what we can write? We can write only if we break this area into infinite rectangles. So I'll go to a random location X and I'll try to draw the thinnest possible rectangle. How thin? Beyond your imagination. It is as thin as you can imagine. It is called dx thin. So to demonstrate, I'll draw it slightly bigger. And now this is a rectangle. But we know this is x and the next line is at a distance x plus dx. So what is the width of this rectangle? What is the width of this rectangle? It is x, it is dx, correct. Now to find the height, we need to know the function. So how the y is changing with respect to x. I need to know the height as x. So y equals to fx is representing the height of the rectangle. Because this rectangle is drawn at a location x, the corresponding height will be this height we can call fx. Understood? So this is not a rectangle, it's a rectangle exactly drawn at a location x, and so its height must be f of x, isn't it? That's called the function. So when you know the function, you know the height. Now can you write the area of this rectangle? The answer yes, you can write the area. So what is the area? The area of this rectangle we can write as dA. So what is the dA value, tell me? Length into width. What is the length here? Come on, we have done
F
this.
of x
F of x. And what is the width?
dx.
Okay. So the area is fx dx. Then how to write? So to get the total area, what will do? You will take all such tiny strip. You'll find the area of each rectangle and you will add it. So what is the way of adding? The adding is called integration. That's why you call the area is the. So the integration is basically the area under the graph. So this is what we do always. So let's try to apply this in a real life. So what is the area of a circle? Tell me, guys. What is the area of
Pi r
circle?
squared.
Pi r square. Okay. Now, how to get the area of a circle using rectangle? So you have to think of elementary. Elementary means the smallest block or smallest shape, which upon replication can give me the entire shape. Okay. So you can think a disc or a circle as a some sort of onion rings or slice, onion slice. So if you look at the onion slice, what you see? You see a stack of ring. Do you see it? Yes or no? So imagine a onion slice. And what do you see inside? You see a stack of ring. Yes or no? Yes or no?
Yes, sir.
And you also realize that every stack is slightly thicker. It is not zero thickness. It is one ring with slight thickness, some thickness, then another ring. So stack means we have a stack of thin rings, one over the other. And if you put in a sequence, it will give you the sense of a disk. Okay. So that any mathematical element is basically a mathematical shape which can be replicated. And that shape should have the known formula in terms of rectangle. So I want to create everything as a rectangle. The only area which exists in nature is rectangle. Every other area we can derive. So the way of doing is something like this. So now very careful. So the first step is, because it is having the radius capital R, so we choose a variable called small r. You may choose x. So imagine a ring at a distance, or imagine a ring of radius r, simply we can call. Imagine a ring of radius r. Now we cannot create a onion slice until it is having some thickness. So the next step is assign a thickness of value dr. What is dr? A very small incremental value. So what we call is, imagine a ring of radius r with a thickness which is almost negligible. Let's call it dr. Second step. And if you look at this thin slice itself, don't look at the entire disk, only look at the thin slice. Take the thin slice outside. So it will look like this. And once it is outside, you know what to do next. And then you cut from anywhere and cut and stretch. Once you cut and stretch, it will look like a rectangle, yes or no? So once you cut this slice, thin slice, I mean thin is, it's like a ribbon. So once you cut the ribbon and if you stretch it, what you will get again? So are we going to get a rectangle, yes or no? So once you cut this small slice and if you stretch it, it will convert into a rectangle. Do you realize this? Yes or no? Tell me.
Yes.
Please.
Shouldn't it look more like a trapezium?
Uh,
The outer radius is bigger than.
no. The dr, what is the meaning of dr? It is so small that the trapezium is close to the rectangle. So
Okay.
imagine the trapezium with the thinnest possible height. It will look like
Rectangle.
rectangle. So this is essentially a rectangle because we only take the radius r. The dr is the thickness part one. Okay. So once you cut it and stretch it, what you get is a rectangle of, what is the width of rectangle? The width will be,
dr.
and what is the length? The length is how much?
By
Exactly. We always take the smaller value. We don't take dr into consideration. Dr is the thickness at r. So our dimension will be decided by the r. We never invoke dr. So we write here as 2 pi r. So what is the area of rectangle? The area of rectangle is how much? We can call dA. So by definition of rectangle area, what is the formula? Tell me guys.
dr
2
into
pi r
2
dr.
2 pi r dr. So to get the total area, you will integrate all such area. And what will be the limit of integration? Where these onion rings should begin from where to where to cover the entire disk or entire circle. The r should vary from where to where?
0 to capital R.
Very good. And that is a logical decision. Huh? So 2 and pi are constants. Can we take it out? So we are left with r dr. What is the integration of r dr?
R square by 2.
So 2 pi into r square by 2, from 0 to r will give you capital R square 2, and you can see this gets cancelled out. So now the question was, why we are taking elementary? Because if you don't take elementary, will you be able to write the area first of all? No. The only area which we all know is which area? We all know
Rectangle.
only rectangle. The purpose of elementary is that it should have a shape which can be expressed in mathematical terms. And you need to remember that the only area which we know is area of rectangle, and any other area can be treated as a rectangle only if you make elementary choices. Okay. And how the choices are made? So we choose a suitable variable and we draw the element. Now this is not the only way of getting the answer. What are the other way of getting the answer? So you can think a disk as a onion slice. In what other way you can think of? So we have to think of all possible mathematical ways in which you can cut. Imagine the situation. Here, I want to find its area, but in a different way. So think of this as a thin slice of potato, and you want to cut chips like finger fries. So it's a very thin, it's like a wafer thin slice. And anyway, we are not looking for the thickness part, we're looking for it's just a shape. So if you cut into the thin finger chips size, so let me draw the x and y. Because we have to cut everything which should have some mathematical meaning. So what we do is we can cut a line parallel to either x-axis or a line parallel to y-axis. See, if you cut randomly, it's difficult to solve. It's just mathematically challenging. There is no other issue. It's just like it's mathematically more involved. So what we do generally, we can cut a line at a certain height. Let's call the height as y. So what is the next logical step? Draw another line close to y, almost y, but not y. So what you do? You move dy ahead and you make another cut. So you make a cut dy ahead and then you get some area. So it looks like what? You can say it's a trapezium, but we have to take this as a closed rectangle. So what will be the width of this rectangle? Tell me guys. The width of this rectangle is how much?
dy.
Dy. Now can you tell me what is the length of rectangle? Given the radius r. So what is the length of this rectangle? Tell me guys. Everyone. Siddhant, what is the length of this rectangle? The width, tell me.
2 into y square minus r square.
Is it y square minus r square? Is
Go
y
into root of
root of?
r square
R
minus
square
y
minus
square.
y square.
Very good. Excellent. R is bigger, na? If you apply the Pythagoras, what will you get? This will be under root of. So the length of rectangle is twice of this value. Yes or no, guys? So we can add dA equals to how much? And now, of course, this is slightly difficult to solve because you need to know the integration. So how to find the area from this formula? So we have to use the method of substitution, and this is particularly based on the trigonometric substitution. So what we must substitute y to get out of the root? The logical. So let y equals to what? What should I write y such that I can come out of the square root term? So you have to answer in terms of sine, cos, tan, cot, whatever. So which trigonometric relation will help you out? Tell me, guys. Garv, tell me. What I must substitute y so that I can come out of the root?
Write it in terms.
In terms of sine, cos, tan, theta, whatever. Any trigonometric ratio should be there. So which ratio should be there in what form, which can let you go out of this root or get rid of this root? Rugved, tell me. Prashansa?
Sine.
Yeah. What sign? Y equals to? Yes, go
Y
ahead. Tell
by
me.
r equals sine theta.
Y by r equals to. So y equals to
R sine theta.
r sine. Very good. And then what you do? You differentiate dy by d theta is how much? Also dy equals to. You can directly write dy equals to.
Sir, here which angle have we assumed theta?
That will theta is not angle assumed. You can just think of theta as some variable, some parameter.
Okay.
We are solving integration. So
So can we use component method?
pardon.
Can we use the component method to write y in terms of r
Right, y
as r sine theta? Can we use the component method?
yeah, of course. So y you can write as r sin theta, and the moment you do so, so dy equals to how much?
R cos theta d theta.
Very good. A equals to you can write as twice of and under root of r square minus y square. So what is r square minus y square now? I will put the limit later on. This is r cos theta, right? So what you get is 2r square cos square theta d theta. Okay. Now I'll just show you the separate integration of cos theta. So what is cos square theta integration? So we cannot integrate cos square. So what we do is we write as in terms of cos of double angles, we write cos 2 theta by 2, and then every term we can write separately. So we can write as 1 by 2 d theta and 1 by 2 cos 2 theta d theta. 1 by 2 is outside, so just a minute. So now the 1/2, the d theta will become theta, and now cos 2 theta we know. Cos gives you sin theta, and 2 is the coefficient, so you have to divide by 2. So the answer is theta by 2. Okay, so you were asking what is theta here. So you can clearly see if y is r sin theta, then theta must be this. Yes or no? If I
Yes,
choose theta like this, then only I can write now y equals to r sin theta. But even though if you don't know this, it's totally okay. You can get it mechanically, but it's good to know theta. So now the question is, how we must vary the theta to get the entire disk covered. So if theta is 0, my line is here, correct? So theta 0 will represent this line. Do you realize this? So if my rod is here, the theta is 0. As theta will increase, my line will go up, up, up. To reach the top of the circle, what must be theta? Can you guess? For what value of theta can reach here?
90.
9. So we must move 90. But if you move from 0 to 90, you will only cover the upper half. So to cover the entire, what we have to do? So we have to turn clockwise, right? Like this. But when you move clockwise from the base, the angle is called negative angle, if you remember
Yes, sir.
mathematically. So to come to the bottommost, how much you have to turn back? So to come to the bottom, you have to turn by pi by 2 bottom, right? So you have to turn by minus 90. So therefore, this integration will be from minus 90 degree to plus 90 degree. But we must start in terms of pi, because pi is the radian, not in degree. And why? Because theta is coming alone. So when theta comes alone, we have to write in terms of pi only. If theta is in sine or cos or tan, then degree is okay. So we write minus pi by 2 to plus pi by 2. Or you can write this way, twice of this answer only from 0 to pi by 2. You just take the half and make it double, because that is going to give you the same answer. So let's substitute it. So twice means theta plus 1 by 2 sine 2 theta, and 0 to pi by 2. So what we'll get here? Substitute pi by 2 plus 1 by 2 and sine 2 pi by 2, which is sine pi, minus the lower limit 0, 0. So anyone knows sine pi value? Sine 180 is how much? Sine 180 is actually 0. So this entire integration is pi by 2. In fact, this is what you should remember, that cos square theta d theta from minus pi by 2 to pi by 2 is always pi by 2. And also sin square theta is also the same. So whether it is sine square or cos square, from minus pi by 2 to pi by 2, you can always take as pi by 2. Okay. So now this will be minus pi by 2 to pi by 2. And this will give you the answer. And so we got the same area through very lengthy method. But this is also a method which we should know. But is this the only way to make the finger fries. I mean, to cut the elementary. The answer is no. So let's have some pizza. So we discussed about the pizza in the last lecture. So what this pizza represents? This represents? Tell me, guys. This is the formula for what?
Cylinder.
Volume of cylinder, right?
Yes.
So this is the volume of cylinder, right? Of radius z and height a, right? This is basically pi z square a, isn't it? So imagine if you have a disk, we can cut into slices, isn't it? We can easily cut into slices. And how the slice look like? So imagine we take a line at angle theta, and to make a slice, we move slightly ahead by angle, very small angle, almost like this, almost like this, almost like this. But to demonstrate, I will draw something like this. And this angle is g theta. So from the definition of angle, can you guys tell me what is this length? So this length is how much? Tell me. This length is how much?
RD theta.
R d theta. So you can imagine, see the tiniest or thinnest possible triangle with base r d theta. So what is the height equals to? This height is roughly equals to how much? Tell me. This height is roughly equals to? Come on, guys.
R.
R. So this triangle, what is the area of triangle? Half into base into height. Basically this is the half of a rectangle. Yes or no?
Yes.
So can we write d equals to half into base into height? So what we're getting? And therefore to find the total area, we have to simply integrate the d theta from where to where? 0 to how much you must turn to cover the entire circle? The theta must go from where to where to cover the entire circle. Tell me, guys.
180. 360.
180, 360. But in radian,
2 pi.
2 pi. So the answer will be r square by 2 into 2 pi and this pi r square. Okay. So is this enough? Or can we cut into other ways also? Now this is something you can call a luxury. So this is, I'm giving you an advanced version of cutting element. And if you can understand this part, then you can solve a variety of questions with great ease. So let's try to understand this idea. So this is the combination of the first method and the last method. What is the first method? Do you remember? The first method was a ring. Okay. And this is the last method in front of you. So what I'll do is I will superimpose both the method on the same diagram, and we'll see a third type of element. So let me draw the first. To make it visible, I'll draw something like this. And I will draw The last one was theta. And then you can focus on the common intersection part. So if you look at this diagram, this is itself is a rectangle, right? And this is theta angle. Difficult to see. This is theta. And this is how much? D theta, right? And the radius of the inner circle is r, and the width is how much? This is dr. So can you guys tell me the area of the rectangle which I have shaded? What is the area of that rectangle? Tell me. Length into width. So width we can take as dr. What is the length? Length is how much?
R.
R. R is the length. Look at the rectangle part. So what I'm asking is, what is this length? This value.
RD theta.
Very good. So can you see the length and width now? So for this rectangle, the rectangle which I have shaded here, this red area, what is the area of this rectangle? Tell me, guys, everyone.
DR into RD theta.
Very good. So dr into r d theta. So how many of you are able to realize this? This is also the area way of writing area. But the problem is, in this case, you can see there are two d's, dr and d theta. So the question is, to find the total area, I have to vary not only one thing, I have to vary two things. So what we do is, we write the two separate integration, one for d theta and another for dr. So to cover the entire disk, the theta must vary from where to where? Tell me. Theta must go from where to where?
0 to 2 pi.
Very good. And r?
0 to capital R.
Very good. And can we integrate both separately? We can integrate now, because this is anyway product. You're integrating two terms and you're multiplying it. And if you do so, what will you get? Tell me the answer.
Pi r square.
So do you realize the ways of taking element? And this is just for disk. We'll do something more. So once the disk is done, let's find the area of a curved surface area. Curved surface area of cone. So what they will give you? They will give you the radius and the slant length L. So anyone knows the curved surface area of cone formula? Tell me, guys, if you know.
IRL.
Excellent. And now this is also rectangle, combination of rectangle. Okay, let me tell you first of all how to make a cone. Like say if you are at home doing some DIY or origami, how to draw a cone. So cone is basically if you cut a slant, you cut along a slant and if you stretch it, a cone always appears as a circle, or you can say circular arc. So it is not exactly circle, it's an arc of a circle. So every cone will appear as a circular arc always. And the length of the cone acts as a radius, and the perimeter will act as the arc length. So basically, curved surface area of a cone is nothing but this area, and we all know how to find the area of a sector. So we know that the entire area of a circle is how much? Pi L square, isn't it? The entire area of circle is how much? Pi L square. Or anyway, if you know the relation. What is the area of a sector? If this is theta, what is the area? So area of a sector is half R square theta, which is half L square theta. Okay, you don't know the formula of sector? Any circular sector will have the area. We have just derived. No? Area is half. But here R is length and theta is we have to derive. What is theta here? Theta is defined as L by R. Arc length upon radius. The moment you substitute, what you get? Okay. Do you realize the answer? Pi RL. So if you want to make a cone, the sheet you must cut as a sector. Understood? Not as a other shape. Okay. You cannot take a rectangular page and make the cone. So to make a cone, you have to make a sector shape, and then you can wrap it. It will become exactly cone with a flat base. But we have to solve it using the rectangle and the integration. Okay, so let's see how to do this. So don't worry, I'll leave after this question because you have other lecture. The next lecture will also continue with the same idea. So for the sake of solving, I have just inverted this cone. But I hope you won't mind if I draw a cone inverted because area remains same. So what we do is we cut elementary parallel to the base. So I draw a circle. So as you can see, if you go from vertex to the base, the thing which will constantly change is the radius. So this ring will have one radius, but this will have another radius. So we can clearly see the radius is a variable quantity. So what we do is we cut a random circle. So you take a knife and you make a small cut around the periphery. Make sure that you have to cut or make this circle parallel to the base of the cone. So let's call this radius as small r because this is the r between 0 and maximum value. So it's some random value, small r. The next logical step is make a small cut, but very close to this circle such that the radius remains almost same. Because if you cut far away, the r will change. But to make sure that R is not changing by any drastic measure, the next circle will be as close to this R as possible. Almost touching. So let me make it slightly ahead so that you can understand better. So by drawing another radius in another circle very close to the first circle, what we make sure is that the radius is essentially same. Do you guys realize this part? Yes or no? So we'll believe that the radius of the two rings are equal. Okay. Now you're cutting a surface on a three-dimensional object. It is not two-dimensional. So this is three-dimensional, and you're trying to cut a surface. So there are certain rules when you cut a surface on a three-dimensional object. The rule is, now I cannot take dy as a vertical. I cannot take this as the length. This we can't. We can only take the slant length as the length of the or width of the rectangle. So the way of taking is to move L. Let's go some small value L, and then you move slightly ahead. DL. So after moving L, you move slightly at called DL. And this width, the width we were taking so far vertically, but now we are going to take a width along the slant. So for surface drawn on a three-dimensional surface, the thumb rule is you will take the width, the change only along the surface of the actual object, which is called a slant. So now tell me, if I stretch this part, I'll get a approximate rectangle. So what will be the area of this rectangle? Tell me. What will be the area of this rectangle? The width is how much? Tell me, what is the width value? What is the width of this rectangle? Can you guess?
DL.
DL. Very good. And what is the length?
2R.
Are you sure? It's a three-dimensional surface, no? So if you look at if you move around the circle, is it 2R?
2 pi r.
2 pi r. Very good. So it is at the end of the day, it's a rectangle of length 2 pi r, and the width we will take as DL, not dy. That is the only condition which you need to understand here. And now the area we can attach dA equals to how much? Tell me. The area
2
will.
pi r into dl.
But the problem is R and DL cannot be integrated together because R is a variable, L is a variable. So either I need to express R in terms of L or I need to express L in terms of R. Then only I can do the integration. So do we have a method to get R and L relationship? And the answer is yes, we do have. Okay. So the area we can write. Okay, then can we relate the small r in terms of small l. Assuming the capital L is given, the full length of the complete slant length is known to you. Suppose this is something which you know. I'll make it like this. Let's call capital L, because I've taken D as a variable. So what is the relationship between small r, small l, capital R and capital L? So you can use the similar triangle, or you can use the sine theta relation. It's the same thing. So this is small l. So we can write sine theta as, in a small triangle you can see it is r by l, but in a big triangle it is capital R by capital L. And therefore I can replace small r in terms of small l. I can do the other thing. I can differentiate this equation. So the dA we can write as 2 pi r. Now r we can replace r by l into l dl, and because everything else is constant, so the total area will be 2 pi capital R by l dl, and the l must vary from where to where? The l must vary from 0
0 to capital L.
and now you know the answer. What is the integration of L dl? Tell me, guys.
L square by 2.
Now you can see this will cancel out. Which means we can find the area of curved surface just using the idea of rectangle. But we have to be careful about taking the elementary, because there are certain you can say nitty-gritties which is involved. So some do's and some don'ts, if you know really well, you will never make mistake in taking the elementary. So we'll see the application of this elementary in the next lecture, hopefully. Now we are only learning the elementary and ways of cutting. All right, so I'll stop it today, and we'll continue the next lecture. The elementary. Elementary will go for almost 2 more lectures, in which you will see the entire physics from the lens of elementary. How you can attempt any question of physics. If you only know elementary, you can probably solve any damn question of physics. If you know only formula and if you know how to take elementary. So you can practically control the physics, that how it will progress. All right. Bye and take care. See you in the next lecture.
Bye, sir. Thank you, sir.
Sir.
Yeah.
I had a doubt in one of those derivations.
Yeah, tell me.
Could you
Bolo. Ek minute. Just a moment.